Today, I'm going to welcome you to my talk, and I'm going to talk about the state of React state. And the title was in 2019, I'd say the state of React state just about yesterday. My name is Lenz. You can find me on Twitter as Fry or GitHub and just about everywhere else as Franius. And I'm a developer at Mayflower. I'm working mainly in the back end of the front end, if you will, so I'm doing the logic and React applications. I've been doing this professional web development for just about half my life, and I've been working with React since about 2016. I'm doing all sorts of open source and a little bit of security and DevOps stuff, but that's not a topic for today. But if you want to talk about it later, I'll be happy to. Why this talk? There's a lot of confusion about state management. If you go into React and you want to know how to handle your state, you might probably have seen this. Here's how to use Redux, some random tutorial on the internet. Then, just a year ago, there was this tweet just as context was coming up by Dan Abramov, where he simply told, yeah, many people were just using Redux, but maybe they shouldn't have, and context is enough for them. Then there was this blog post, Redux is dead, followed by a talk, not dead yet, by Mark Erickson, the current Redux developer. People on Reddit all the time tell you to use mobx instead of Redux. The hype train on Twitter says just use GraphQL for everything, even for local state. Then there was, again, this context idea, which has mainly been driven by Can't See Dots right now. And again, the hype train, add hooks to everything. But this is confusing. There are so many solutions, none of them explain to you why you should use this solution, and even if you know which solution to use, you don't know how to use it, because, let's be real, most of your state won't be in one of these libraries. There's so much more to state. And before we continue, a brief warning. A lot of this stuff, especially hooks, is so changing right now. These are experimental APIs, these are alpha versions. I think most of this talk should be really up to date, but at least one thing has changed during my flight yesterday, so there's not much I could do about that. First thing, what do we really need to look at? We need to look not at solutions for state management, but at our state itself. What are types of state in React apps, and how does that state affect our general picture of state? How should that state be handled, and what makes it so special? Then we can talk about libraries, and after that we can talk about what you should be using. So what do you want to look at if you're looking at a specific type of state? The first thing is if it's local state or global state. Many people just tend to cram everything into the global state, which honestly not always is a good idea. If you can keep state local, you really should. So we're going to take a look at, is this type of state a global state? Is it a local state? Or is it somewhere in my component tree in between? Is it almost global, at least for a big part of the application? Or is it more like, yeah, I have a form there, so it's local for that form or something? If you go pure global state, that has really good points, because you see all your state of the application at once. You go into your Redux DevTools and everything is there. You can time travel and everything. But the bigger your app gets, the more you lose accountability. Which component can change that state? Which component uses that state? Which developer in the first place is really accountable to work on that state? If you move to local state, on the other side, you're losing a bit of the big picture. And if you're mixing global state and local state, you might use time travel, and not everything in your application is time traveling. But essentially, that's okay, because only you as a developer will be using time travel. Another thing to look at is how often does a state change? And that's from a form where whenever you type, the state change. I'm going to make this a little bit bigger, I'm sorry. That updates your tree every now and then while you're typing, and it just impacts a small portion of your application, so it's fine. But if it's a real global state that impacts everything, you might want to know how often does it change, because yeah, that has performance impacts. Also, you want to take a look at how that state is initialized. Some state is not initialized at all or with some default values, but other state is initialized asynchronously. There might be a call to a local database on the browser, or a call to an external API that still has to settle, and you have to have a loading state in between and such things. Sometimes, for example, for login, you might even want to start loading that state even before the React app starts rendering. So you have to start this loading outside of React itself. And then there's the question how updates are triggered. Updates can be triggered by component when we are mounting or when we are unmounting. Updates can be triggered by user interaction. Updates can be triggered by the lifecycle of a complete application, like I said, when it's first being rendered, even before React is coming into the picture. So this might actually impact your choice of state management, because not every management library has a good solution for that, and you might be working around some things. And all that said, let's really look at types of state you have. Yes, that one big state, or no, it's rather small actually, but it impacts a lot. That's configuration state. It's the language your user is using. It's the theme your user has activated. Maybe some other things that really impact your whole application. That doesn't change a lot. It essentially just changes if the user goes to the settings page and does a change there. But it impacts your whole tree. So this is true global state. And this might be initialized from outside, from some storage, or even from the server. Another type of state would be user authentication. This is initialized in two different ways. It's initialized by the user in an asynchronous way by sending a login form, or it's initialized by a JWT you have lying somewhere around in storage. Again, this is true global state, because it will most likely impact your whole application. And again, this is something that changes really rarely. Another type of state is input state or form state. And this is the complete opposite. It only really impacts the form you're currently entering information in. And it holds, well, the information that's entered and maybe validation information. This will change rapidly as you're typing. Every keystroke will trigger a change in your state. So often it's a good idea to keep this as local state. You can transfer it to global state if you have a multi-step wizard, but I would say this is local state as long as you're entering into that form, and then becomes global state when you're sending the form and going into the next step of your wizard, because only then it's an input for the next part of your wizard. Oh yeah, and changes are triggered from closed component most of the time within that form. Then you have things like UI state, and this is just, is this accordion open? Is this toggle activated? Do we have a checkbox here or something like that? This is usually true local state. If you're refreshing the application, it doesn't matter if it's in the same state as it was before or after. If you're navigating away and you're navigating back, then usually it should be in its initial state, not in the state the user left it. If you want this to be global state, this might become more complicated, because what if your component is used twice in your application? So you have to keep track of component identity. Component A on page A needs to have the toggle open, and component B on page B needs to have the toggle closed. So this is something I'd rather not do if possible. And yeah, these are initialized with default values, and changes are triggered most often from the component itself or a component close to them. Another state is API cache. This can be global or local. We will take a look at why and how you would do this. Usually it's normalized values, but it can also contain denormalized values. Usually it's initialized empty. Changes are triggered somehow asynchronously, maybe on component mount or maybe on user interaction. And the big thing about API cache is at some point in time you want to invalidate this. And then there's this last part of calculated values, or simply memoization. These are derived values. Deriving them may be a little bit expensive, but essentially these are values you can just throw away, and if you need them again, you can just recalculate them. So usually you wouldn't keep those in global state, you would keep those in the component that needs it, and if it's unmounted, it's not a real problem. So I talked a little bit more about cache state here, and that's the real big elephant in the room, because I got the impression that at least 80% of every global state that an application has is somehow API cache. And we really should get away from that. And this is where GraphQL comes in. If you are using GraphQL, you are most likely using Relay or Apollo client, and they do all the caching for you. GraphQL is perfectly normalized. It's perfectly normalized, and cache invalidation is just not a problem. Everything is always in sync. You won't have to worry about that. And this is the main idea. If you can go GraphQL, you should use GraphQL. If you still have REST APIs, you might want to take a look at Apollo Link REST, which allows you to take a REST API and use it as GraphQL from your application. Or you might want to create a facade that's a GraphQL endpoint for your application. So your application doesn't have to worry about that. If you're not using GraphQL, then you can make the decision if your API cache is local or if it's global. If you're using the same API at two different places in your application, then you have to go global, that's sure. But if it's just in one place, then you might want to think about keeping that state local, because once that component is unmounted, the state is gone, and you don't have to worry about invalidation. That would be a big win. And also, there's nothing really I can tell you here. There aren't any good libraries I'm aware of to solve these problems. Everybody does it on their own, and since we could be talking about this for the next 3 or 4 hours, I'm not going to talk about any more cache state over here. Let's just assume we have a solution, because otherwise we can't continue. After we're done with cache state, there's not really an elephant, but let's say there's a donkey in the room still, and that's form state. It's just not fun to handle form state. You have asynchronity when sending forms. You have validation that might happen synchronously or asynchronously. The user is typing all the time, and this gets frustrating, and you don't really want to do this. So don't. There are libraries to do that for you. You don't have to know how their state works. It works. Formic is great. React Final Form is great. These two are actually recommendations from the Redux team themselves, because their FAQ says don't keep form state in Redux or in global state. So also take that out of the picture. And if we are taking these two out of the pictures, the big question is, what are we left with? Well, it highly depends on what your application looks like, but usually you have configuration at login state, which is not a lot of state, and that's the real global state, and very much local UI state, and a little bit of semi-global or semi-local state in between. And I guess that's a typical scenario, so let's see how to approach that. And the first thing we should look at is how to approach that with React alone. And here we're going into demo territory, and we're also getting into hooks territory, because writing new demos using anything else, I think would not make much sense. If you scan that barcode, this will get you to the GitHub page of this talk. There's a branch for every demo I've put together, and the talk itself is there too. I guess there will be a link on the homepage of the conference later on too. And I'll just jump into the source code. There is a big part on using hooks with local state with React that I'm going to skip because I just noticed it takes too long. But it's in there, it's example 1 to 5, and you're really invited to experiment with that. The first thing we're going to look at is how to use context to share application state without having to do prop drilling in between. So the concept of context is simply you have a provider somewhere up in your tree, and every component beyond that can access to the value that is provided by that provider. Always for one type of context, the closest provider for that type of context. So you will have to use a different type of context for every different type of state you're using. Let's get this. Nice. This example is taken from Ken C. Dodd's blog, where he's doing a lot more on exactly this example. So this is the reading recommendation. He said I could use the example, and he gets the link for it. Essentially, first thing we are doing is we create a context. This will give us two components, a provider component and also a consumer component. And we're not going to directly use these, but we're going to wrap these. First, we are writing our own provider. Our provider has one state, which simply is a count for our counter, and our value will be the counter itself and a function to modify that counter. And we will pass on these two methods, or this value and this methods, via context to all context consumers. If you wanted to consume that context, we could use this consumer we would be getting from context, but we can also use the react.use context hook. So this will essentially, used in every component down the tree, will give us these two values as an object named context here. So we check if we have a parent context, we destructure it into the count and the set method, and what we are doing here is we wrap it again because we don't want to expose this set count method to the outside. Instead, we want to expose an increment method. So we are wrapping that just as a new function that increases the counter by one each time, and we return count and increment to the outside component using this hook. Looking into the example, how we use it. This is my component tree, just to show that this can be deeply nested and you don't have to pass any props around. We have our provider at the top, and two components down here and down here using that context. The one component, no, there's the wrapper components. Yeah, the one component is just interested in the count. So it says use count, destructures count from it, and displays it. The other component, on the other hand, is used in increment. So we extract that and have a button that does this increment. If we look at it, example 5, we have, no, example 6, my bad. We have this button down here that calls increment, and we have it up here. This essentially is what we want to do most of the time if we need global state. So in many cases, this could already be enough, and you won't need a state handling library. To put all those state handling libraries more into context to each other, I have a small baseline example for every of them, which would be, let me reload the page, this login form. Essentially, the form starts empty. We want to do initialization, so we want to do an asynchronous call to some storage API or something to get the information if the user is already logged in. And if the user isn't logged in, we want to have this form. We get informed about wrong credentials, and we can successfully log in. So you're logged in, and then we can log out again. This is a baseline example because it showcases many different things we want from a state management library. Using context, this example is not too complicated. At first, we have the things that will be similar between all implementations. We have these simulated fake data fetching things. Essentially, load user from local storage just says, I got no user after a second, and simulate login checks for test and returns a user. Otherwise, it returns undefined. The form is no magic either. That's just a standard form. So we don't have to worry about that. And this is what the app itself looks like. We have a use login hook, and we will have almost this implementation everywhere too. That use login hook returns if the application is currently loading, if the user is logged in, if the user is there, if he exists, if an error has occurred and what the error was, and gives us two callbacks to log in and log out. So if you're loading, we are just showing this initializing please wait that we saw here for the first 2 seconds or first second. If the user isn't logged in, we show the login form. We probably display an error, like a validation error. We'll trigger the login method, and otherwise we show this, you are logged in as user with this role, here's a logout button. So this will be very similar between all implementations too. What we really have here is the login context itself, which is not that different from our example before. We just have a state that contains a little more. It contains a user variable and the error variable, the information if it's initialized. We memorize that. And one thing here that's special is we want to do this loading of the user information as soon as possible. And since we are doing this within React, we can't start this loading process before React has started rendering. So instead, we do it as soon as this provider component that's absolutely at the top of the tree is mounted. We just trigger an effect that calls our asynchronous method. And after that asynchronous method has settled, we set the login state. So either we have a user or we don't have one, but we are definitely initialized by now. So no loading message anymore. And then we have this use login hook. We have a login method that essentially waits for the simulate login. And if we have a user, it sets the user. Otherwise, it sets an error. And a logout method. And then we give all those out. And additionally, we have two calculated values here because I also wanted to showcase how each library handles calculated values. In this case, we just calculate them in the context hook. So loading is we are not initialized, and logged in is we have a user. Having gone through all that, maybe this might be enough for you. Some best practices to put in the front. If you're going with hooks and you're going especially with local state and you're just using use state, you might want to take a look at use reducer. The examples will show you why. Essentially, from use reducer, you have access to your props at a later state of rendering. If you're just using that state with a callback, you don't. And sometimes there's asynchronity where you need that. Always lifting your state up to a related parent component, if you have the same state in two components, is always a good idea because otherwise they will run out of sync. But if you get two nested props there, you want to use the child property, the children property, to just nest optical components without having to pass everything through there 1,000 times. If you get to too much prop drilling, this might get a semi-global state and not semi-local state. So you want to start using context. And still, you want to use context not as far up in your tree as possible, but as far down in your tree as possible, because it will affect the smallest part of your application. And you really know what part of your application is actually impacted by this, which is important information. Also, there are limitations. If you have just this one big context object that affects just about every of your components, if you change one thing in there, all of them will re-render. So that might not be the best thing. So you will start splitting up your context into many smaller contexts that are dependent on the theme, essentially. Having that might mean that you have a dozen or more context providers in your application, and that might be suboptimal too, because it's not really nice to read. Alternatively, you still can have that one world object and handle your own subscriptions on it and just pass a subscribe method down. That's what Redux does internally. But already today, we know that this will break with concurrent mode. That's okay for Redux because they are a library and their sole purpose is solving that problem. And they are in very close contact with the React core team. But you are not in close contact with the React core team, and it's not your job to solve these problems again and again. So please don't do subscriptions. It will cause you pain. And another thing is you can't just plug in a new context provider at the top after your app has started rendering, because that will move the whole tree one down. And every component beyond that will lose its identity, which means it will be a completely new invocation of that component, and it will have a new state. It will start with an empty state again. So you just can't add plugins or modules at runtime. That's something to keep in mind. Another thing to keep in mind is that when you are performing asynchronous actions, there's no way of really getting the state at a later point in time. Because when concurrent mode lands, a state setter might be called 10 times until the component is finally rendered and the state setter really changes state. So asynchronicity might be a red flag for you, but only in very specific cases. If these limitations don't bother you, you might already be using a perfectly fine state management solution, which is React itself. If there's more to it, or you want your logic further out, or you want to use middlewares or something, then we might have to take a look at a library. So let's do that. The first thing we're going to look at, because everyone calls it the so simple and so easy one, is mobx. I've prepared just the same application we saw just now in mobx. Yeah, that's working out great. In mobx, you can do this a lot simpler, but I wanted to have it comparable. So I started by defining a model, which is a class with observable properties. So this class is called login. It has the same properties we saw in the state before. It has user, it has arrow, it has initialized. These are marked as observable. Please ignore the red underline. My VS Code doesn't like the decorators here. And we have computed props. We have this loading prop, this logged in prop, and we have actions. This is a simple action that's directly bound, that just sets the user to undefined when called. And we also have two asynchronous actions. These are written as a flow that is wrapped around a generator. And for every asynchronous call in mobx, within a flow, you just yield your promise. And after a while, you get the value back, and the flow continues to run. So we are doing our wait for 1 second and return undefined. And then we set the user to user and say, yep, it's initialized. The login flow, again, you've seen it. It's looking a little bit different, but this is a flow, and it calls the simulate login method and checks if there is an API user. Otherwise, it shows an error. The user itself is a super simple model. It has a username and a role, and we have a constructor here because that's making it easy. In your application, this would usually be your main JS. We create a state outside of React, and we directly call the initialize method. So this initialize call already starts before we are even rendering anything in React. And then we are rendering, and we are rendering this provider with the login state as login. You can name it whatever you want. Also, we are rendering the dev tools. You can play around with these on the demo if you want to. Within that, we render our app. Our app, and this is a little bit different, is a function component that is wrapped in two other functions. The first one is we inject that login state, which means within this inject call, we have props.login, which will be the login property from our provider further up the tree. And also, every method that uses any observables has to be marked as an observer. If you're using class components, you can use the observer decorator. If you are using function components, you have to wrap the function within it. And then you can just use with this login without any further thoughts. So login is loading, we are waiting. If we aren't logged in, we show a login form. We can directly use these methods on login. We don't care if it's synchronous or asynchronous. This is really simple. Also, it would be possible for me to directly write into the state. So I could just write login.user equals anything, and I could just write in there. I wouldn't really recommend doing that because it makes the data flow in your application really weird, because every other component will pick up that change immediately. So you never know which component triggers which state change if you start using these things. But it's possible. Yeah, back to the presentation. So in mobx, state objects are observables, and components, on the other hand, are observers. This is either denoted by the observer decorator, or the observer wrapper around a function component, or the use observer hook, which I didn't show because A, it's experimental, and B, I tried it. It doesn't give any additional value for me. So I think for now you should stick to this. You have computed values. These are lazily computed, so they are really just computed if they are used. So you can have thousands of them and use only 5, and only 5 are ever being computed. Asynchronous actions are handled with flow. And any number of small mobx stores can exist, and your provider can pass down just a few dozen of these small models. If you want to use any side effects, there aren't really middlewares, but you can use reactions that listen for changes in specific parts of your state and get executed when something there changes. So that's almost as good as a middleware, I guess. The next step up from mobx, more mobx. This is ultra unopinionated. You can modify the state objects directly, as I said, or you can use actions, and you can even enforce the enforce actions mode, which means you can't from that point on do direct modifications, and I really recommend that. And as I already said, the data flow here is really un-React-like because it's not top-down anymore, but it's more like whatever component wants to change something, it changes. And this is in line with what mobx wants to do because they say that they want to make React more reactive. So if you can wrap your brain around that, that's great. But it might, on the other hand, for a traditional React developer, be a bit weird. You can also use mobx for local storage, but, well, React local storage is good as well, I think. The next player would be one step up, mobx state tree, and that obviously internally uses mobx, but it's much more opinionated, and it gives you a kind of architecture that you should be using. So the main difference here is if you take a look at the model. This model is type safe. This is a runtime type checked while you are in development mode, and you create this model like this. So you say, I have a new type model. The user is maybe, which means I think undefined or a user. The error may be undefined or a string. And initialize can be depicted at creation, but you can also omit it, and then you get false for undefined. For calculated values, here we have a view on this model. So we have the loading view, and we have the logged in view. And then we have the actions, which essentially are the same as they were in mobx. So you just have your flows for asynchronous actions or simply normal methods for synchronous actions. In the user, there's not much of a surprise. And if you look into the index file, we're not doing new login anymore. We are doing login create anymore now. We could also pass something in here like initialized as true or something, but that would ruin our app right now. So I'm not going to do it. Also, outside of React, we're immediately calling initialized, and then we're rendering the whole thing. Provider works just as you were used to, and the whole rest of the application just works as you were used to, because the bindings from state to application is still the mobx-react package, and everything is exactly the same there. So, what did we see? Mobx state tree builds on mobx, and it's very opinionated. It's not like, here's something you can do anything with, but it's like, here's a solution, please do it that way. And I live with that. I think it's nice. You have type-safe models that are checked at runtime. Enforced actions is on per default. You can deactivate it, but I wouldn't recommend it. Something we didn't really see, but that happens, is that while mobx state changes, mobx state tree is a copy on write model. So your action might look like it changes the state, but actually it changes a draft of the state, and it returns a new copy of the state that's modified. And you won't notice it while programming, but it gives you things like time travel. You get snapshots between two states to synchronize them somewhere. So that's quite nice. The computed values are in a view. All models can have lifecycle hooks. So an instance of this model was created, or this model was attached to a tree where it wasn't before, or we are going to take a snapshot of this model because there was a change. mobx-react has middlewares if you need them. Also, it has action listeners, and as it's internally just mobx, it also has reactions like we already saw. Next thing is Redux, and I'm not focusing purely on Redux here, because if I wanted to showcase you Redux right now, I wouldn't know where to start. Redux is so versatile that every single tutorial will give you a different way of structuring files, of just doing anything completely different than any other implementation. So that's not really useful. What I'm going to focus on here is Redux Starter Kit, which is just like Apollo State Tree. mobx State Tree is an opinion version of mobx by the creators of mobx. Redux Starter Kit is an opinionated version of Redux by the creators of Redux. So I can show you something that, looking at the documentation, everybody will be able to relate to. Also, this might be new for some of the Redux users, so it is really cool. Okay. So, what we have here is a new concept. You aren't creating actions and reducers and somehow putting them in different files and a third file for your constants and everything. No, you are creating one slice. This slice may have a name for debug reasons. It has an initial state, and it has a bunch of reducers. And for each of these reducers you write, there will be an automatically generated action creator for exactly that reducer later on. So you don't have to worry about writing these, which honestly was a big waste of code and time. Further down, we have some selectors for a state, because that's how we will use the state later on in our components. I have this one called select login info, which selects our login slice. And then from that slice, selects these two computated values and this direct value. So we are doing the computation here within the memoize selector. Also, I have a second select user selector, because my idea was maybe in a bigger application, you might not always need all 4 values, but sometimes just that one value too. What Redux Starter Kit comes with is Thunk per default as a small middleware for asynchronous things. This won't hinder you from using Sega or anything, but you have something out of the box already. So if you would be writing a thunk to do this asynchronous initialization, that would look like this. We have a function that returns a function that takes dispatch as an argument and then executes our stuff. The login thunk, I think, looks like you already had guessed. We do a simulate login, and then we have 2 different actions we trigger, and this action actually directly corresponds with this reducer. And this action is directly generated from this reducer. So it's essentially just call this reducer with this argument, but if there are middlewares, they might handle this. So it's coming a lot more together than before. From the main.js side, there are changes too, because creating a new store is much more simple with Redux Starter Kit. If you use this configure store method, you just pass in the reducers. Dev tools are already taken care of. There's already the thunk middleware in there. And after we have created the store, we do our asynchronous initialization outside of Redux, as it's possible, outside of React, sorry. And then this might look familiar. We have a provider that puts our store into the application. And within the application, this is exactly the same line as we had in our React demo. Because I've started writing a few of these, and I noticed, hey, I've always the same pattern. Let's make a hook out of it, because this implementation down there is absolutely ubiquitous to what we are using. The actual implementation of this use login hook is up here. We are using the selector for the login info. We are also selecting the user. We're getting a dispatch. And we have these two callbacks that dispatch our login thunk or our logout action. This, on the outside, is exactly the same application as the last four we saw, last three. So, first, Redux only. Redux has a unidirectional data flow, which means every change you want to make to your state is made through an action that you put into one dispatcher that's sitting at the top of the application. That dispatcher takes that action, passes it through all middlewares, and in the end to a root reducer, which passes it to other reducers. So you have a really defined flow of state and state modifications here. Not everything can just modify everything. Middlewares can be hooked in between, and components have to be somehow connected to the state, either by the connect method that you might be used to, or the use selector and use dispatch hooks that I showed off here right now. Usually you just have one Redux state that's kind of a tree in your application. Using Redux Starter Kit, first thing, this is from the makers of Redux, so this is semi-official, and it's not the 3000th solution to make Redux easier. No, this is official. This is very opinionated. That gives you a great experience out of the box. You just can use it. This includes Redux Thunk, and it also includes immer, which you might have noticed something weird with my reducers. These reducers just modify a draft. So this is exactly as we saw in a mobx state tree. We get a copy out of it, even though it looks as if we are writing. And this will bring down the code of your reducers by about 80%. It includes selectorator for selectors also. That might not be set in stone, because this is still pre-version 1, I think. DevTools are enabled out of the box, and it brings a lot of quality of life functions. We have seen configure store, we have seen create slice. There's also create selector, create action, and create reducer if you need these. Using this in comparison with your traditional Redux application will make it smaller and will make it easier to comprehend. So if you are already using Redux, there's nothing from stopping you to just plug this in and use slices for all your future states while perfectly working with the old states. And then we have a new kit on the block, which is Apollo Client. Earlier I said use GraphQL for everything, and when we are using GraphQL for everything server-related, why shouldn't we also use it for everything client-related? And I'm looking at the time, and I don't have much left, I think. I'm going to do a jump start at this. So from the app side, we are just doing GraphQL queries against our client state, which looks very nice from this side. And if you're already using queries and mutations, you can just stack these into each other, and you can even combine local and remote queries in one query. from the implementation side, this is kind of a hell right now. I'm sure there will be libraries to make it better, but right now you have to write every of these mutations yourself. And what you really do in these mutations is that you modify the local cache of Apollo. And yes, you can do that with fragments and everything, but this is the one point where if you're using TypeScript, type safety completely breaks away. And I'm waiting for something like Nexus for GraphQL on the server side to work here on the client side, and then it will be super fine, but right now I'm not aware of a library that does it. So if you are going this approach, just fork the example, play around with it. For me, this really feels clunky. Also, no support for middlewares, but you can do asynchronous mutations if you want to do that. And initializing your state is really just writing into the state of your data. Also, as everything in there is normalized, each state must have a type and an ID. So you will have many states with ID 0 and just one of these states. Well, it stores a state in Apollo cache. It can be subscribed just like subscribing to anything if you're using GraphQL. State modification is either done by directly writing to the cache or creating local mutations. Everything in there is normalized, and for me it feels absolutely clunky. If you're poorly using GraphQL, this might still be a shot for you, but if I had the choice, right now I wouldn't use it, but I would keep an eye on it because this has potential to become very, very great. Short word on testing. In everything but mobx, I had this thing where I use my state hook outside of the application. And if you use a pattern like this, where you inject an implementation as a prop, then you can use this for mocking and testing. And this means you can simply mock away your global state. You could also use this to mock away your client-side state, but then you would not be testing your component anymore, but it's implementation, and you really shouldn't do that. So what should you use if you have an existing project? Are you fine with it? That's fine. Is something wrong? Then evaluate what you are doing. Maybe you're missing something. Maybe there are best practices to make your life easier. Does it help if you add a library for cache or forms? Is it getting better if you're moving out from global state to more local state? Because many people make the mistake putting everything in the global state. And if after all these tries and trials, you're still unhappy, then you might have to take a look at another state management solution. But if it hurts you in one state management solution, it might also hurt you in another state management solution. So really take a look at your architecture as well. If you are starting a new project, look at your team. Do they know a library? Great, use that library because, well, they know it. They don't have to learn a new one. If you are thinking about choosing a library, analyze your state. Is it more global state? Is it more local state? Is it often changing? Is it seldom changing? All these things we did. Can we add a library for cache and forms? And the next points are the same as the slide before. How about moving global state to local state? And yeah, then definitely experiment a bit. But there is really no holy grail. And as a conclusion, there are many good options. The differences are primarily philosophical, especially when we are looking at the hooks implementations. These are very similar in usage, and it's more like I want my data flow top-down or I want to modify everything everywhere. Whatever works for you really will work for you. There isn't much more to that. And having said all that, don't fall for the hype train. Because being too much on Twitter is the worst thing you can do for your application, really. Yeah. I think we have time for question and discussion outside. Sorry.